Lights, camera, fractions, even though we didn't turn off the lights.
Okay, good. All right. So, yay. So we're moving into a factoring part of the class, and factoring is outrageously important. And factoring is taking something big and breaking it up into its little parts, right? And I love one of the things. This is actually my favorite part of algebra by far. My favorite part. This, and as we move into quadratics, because you do a lot of factoring in quadratics. One of the things I like about it is that symbolically, it's a really valuable thing in real life. When you think about it, if we keep problems in our real life huge, it's almost impossible to make a dent in them. Do you know what I mean? World hunger, right? Really hard to solve, right?
Donald Trump.
But suddenly, you start to think, sorry. Okay, we're not going to be political in this one. Anyways,
Homework.
I could say something, but I'm not going to. But we're not going to. If you keep something in something big like world hunger, then it's like, oh my God, how am I going to ever possibly make a difference in world hunger? But if you remember that world hunger also is homeless people or people hungry in Santa Fe, New Mexico, or in the state of New Mexico, or in the United States, or whatever, and we can actually make a change on something smaller by breaking it up, something huge, a world issue, into smaller factions. Does that make sense? Then we can feel empowered to make a change and do something. And we'll see the change locally. Now, if everybody did that locally, globally, world hunger would cease to exist, quite honestly. It's an amazing thing, right? I mean, there is going to be a time when we have to figure out, okay, some countries don't, produce as much food as we do, and therefore we may have to share. We have to try to figure out how to transport food from one place to another. So, but anyways, it's a wonderful concept. Take big issues and bring them down. Figure out what are the little parts of it, so that we can actually deal with one thing at a time. Yes, Zane.
What is the difference between a fraction and a faction? You said faction.
Did I really?
Yeah.
Wait, did you say difference between
Different
faction and
faction.
fraction?
Yeah.
A faction is like an area or a group or something, I
Yeah.
think, and then a fraction is a number. I don't really know.
Like
Okay.
with a numerator and denominator. Yeah.
I just realized,
I haven't said my fraction.
Okay, guys, Troy.
I just realized that math can be very philosophical sometimes.
Oh, it can be.
It's
Big
so
time.
weird.
Yeah, it really is. But so factoring, in order to really truly master quadratics and parabolas, you have to know how to factor. And so I'm starting with stuff that is not going to be quadratics, but it's very quickly going to be moving into quadratics. Probably, we'll definitely next week. I don't know if this week we'll get into quadratics or not, but next week we'll be into factoring quadratics, which are things with y equals ax squared plus bx plus c. You already know that. You know how to graph them, but you don't know yet how to factor them and what the value of factoring is. But first we got to just talk about factoring in general. So factoring, let's just first say, what are factors of 12? Factors of 12.
3, 4, 2, 6.
Yeah.
12.
So, right, you can do a factor tree, right? You can do a factor tree, right? So I could say 2 times 6, right? 2 times 3.
2 times 4.
Obviously, 1 times 12.
I mean, 3
right?
times 4 for the
12. So all our factors would be 1, 2, 3. Oh wait, we didn't do 4, did we? Oh yeah. And then 2 times 2 is 4. 6 and 12, right? Those would be all our factors. Factors are numbers that you multiply. You multiply. You don't add. You multiply times each other to get another number, right? So factors of 12 are all the numbers that you could multiply together to get 12. Does that make sense? Yes.
Wouldn't there be an infinite amount of numbers because there's an infinite amount of numbers between 1 and 12?
Technically, yes, but when we're talking about factors, most of the time we're talking about whole numbers, integers, okay? Integers, which are whole numbers that can be positive, positive, that can be negative, and they can be 0. Okay? Yes, you could factor out a 2.3794 out of some numbers, but it's not as easy. It's easier to just think in terms of whole numbers for these kind of things, or integers. Okay? So now that we know what factors are, I guess you guys already knew that, it sounds like. But what if I said, find the greatest common factor? Greatest common factor, find...
Oh, I know how to do this.
We did greatest common factor like 8 years ago, Gary.
Greatest common factor between...
Like 2 years ago.
All right, so 12 and 15.
Like 4 years ago.
12 and 15. Greatest common factor. In other words, what is the biggest number that goes into both of these numbers?
Yes, 4 years ago.
6.
So-
No, 4.
3.
4.
So we've got 3 times 4, right?
Oh no, yeah.
So
3.
this could be 3 times 4. This could be 3 times 5. So that sounds like it. So 3 would be my greatest common factor, right?
Yeah.
All right. What if I had 12 and 60? What's my greatest common factor?
12.
12.
12.
12, exactly. Because 12 divided by 12 is
I said it first.
12. I mean,
Everyone.
12 times 1 is 12. 12 times what? 12 times 5, right, is 60?
Yeah.
So 12, right. Okay, so now that you guys know that, is everybody okay with that? You guys understand this? Does it make sense to you? All right, so now that you know that, now we can do what the real lecture is about.
Yeah,
You
have
guys
we
remember
started
the
video?
distributive property, right?
No. Yes. Yes.
Have we started the
So I'm
video?
gonna, yeah, the video is running.
Okay.
So, first of all, let's just look at the distributive property. The distributive property. Let's say I gave you 2 times x plus 4. Okay?
2x plus 6. I mean 8.
So if I used my distributive property and I do my arcs, 2 times x is 2x plus
8.
2 times 4 is 8. Everybody knows that, right? Everybody. This is
Simple.
like it's so simple, right? Everybody's got that. Yeah. Tens. I'm seeing tens. That's what I want. Right.
I don't know how to do
This, when we factor, okay, guys, listen. When we factor, Jax, when we factor, we're going backwards. We're going back to this. This is in factored form, right here. This problem, look, nobody's looking up here. This is in factored form. Remember, it's a number times another number, or a group of numbers, right? X plus 4 is a blob, a binomial. It's a number times a binomial, right? So that is in factored form. This is not in factored form. So the whole goal of this lecture is to take this and go backwards back to this, okay? So let's try it. Let's just try it with this one. We know what it is. But what is the greatest common factor between, so Maddie, where's your notes?
2.
Can you put that away completely? Because I need you to be paying attention. So 2 goes into 2 and 2 goes into 8, right? So I'm going to immediately, this is what I'm going to do. I'm going to go like this. I'm going to put a 2 here and I'm going to put a parenthesis. You guys with me?
C.
And what I'm going to do is I'm going to divide 2 out of this and 2 out of this and put that here. So in essence, this is what I'm going to do.
Divide it all by 2.
Right.
Get
That's what I'm
1
doing.
X.
And so, because I'm taking this 2, I'm dividing this 2 out. So what would I get? This would become 1x, or just x.
X plus 4.
Plus 4. Right? Does that make sense? You guys see that?
C.
I think we did this last year. Did we?
C, senor.
Did we do this last year?
I don't remember.
Okay.
No.
Okay.
No.
Alright, so let's try a few. Here's number 1. Alright, how about 4x minus 16? Alright, what is my greatest common factor? What's the biggest
4.
number that goes into both of them?
4.
Divides into both of them.
4.
4. So I'm going to put a 4 here, parenthesis, And then I'm going to divide the 4 out of this, and I'm going to divide the 4 out of that. So what would that give me?
X minus 4.
X minus 4. Now, we can always check it, and it's so easy to check them to make sure you did it right. 4 times x is 4x. Yes. 4 times negative 4 is negative 16. Yes, we did it. Right? It's so easy to check them. Okay,
Wait,
let's try
so
another one.
it's just like a big circle then. It's just going, it's looping back around.
Yeah, it's looping back
That's
around.
so weird.
So we're going from the something that's already been distributed back to the factored form, which then we could distribute, which then we could go back and factor. And you could do this all day. This could be a fun.
So this is like
Next time you have a day off, this is the kind of thing you could do all day long.
this is
Oh
like
my
Jeopardy.
God.
You give us the answer and we have to figure out the problem.
Yeah.
Forget video games.
Okay, here we go. Yeah,
Yeah,
forget
forget-
video games. Like
I'm gonna
that.
do math all
This
day.
is way more
I'm not gonna
exciting.
practice my
Okay.
trick shotting.
All right, so here we go.
You can't even trick shot scrub.
I,
Game trick
I can
shot
put
like
them
Minecraft.
lightning.
Okay, 5x minus 35.
Oh, 5.
5 goes into both of them, right?
We don't talk later.
So
It's x minus 7.
5
5x minus
parentheses,
7.
divide by 5, divide by 5. I've got x minus 7.
So I did it right.
Right? Yes, you got
Or
it.
did he?
Good job. Now, I'm going to make it a little harder now. Okay, I'm going to make it a little harder. Here's another one. We on here still?
Stop. Stop.
Um,
Stop. Stop. Stop.
Okay, 8x plus 12.
No. No. So I
Okay,
know.
8x plus 12. Somebody different. Somebody different.
Gary.
Nothing.
Okay, Maddie.
Okay, so 4 is the greatest common.
4 is my biggest common denominator that goes in
4,
there.
2x plus.
And I'm going to divide this by 4 and divide this by 4. And so
2x plus
2x
3.
plus 3.
Is he right? Maddie?
This is what we were about to buzz.
Maddie, is that what you're going to say?
This is
Yep.
so fun.
Isn't it fun?
No, I'm serious. This is
It
really
is.
fun.
It is. I
Or
agree.
is it, Jake?
Is this gonna be our homework?
Yeah. This is
Yay!
Oh, this is easy.
Okay.
Gary.
So,
say-
now.
Don't say it's easy. Say it's really hard, so we'll give us like easier stuff.
So
later.
3, 4.
You just told him our plan.
Well, you're ruining it.
So are you.
What if I gave you
Well, you're ruining it more, Jake.
Like,
24x minus
Four.
It's 2 against 1. So
60? 24x minus 60.
What is the
24.
Four.
It's
That's-
20. It's
Does
x.
24 go
24.
into 60?
Yes.
Yes.
Maybe.
24.
What?
40. No, wait, hold on.
6.
12.
No.
12. 12. 12. 12.
What do you think, guys? What's the
12.
biggest, greatest
12.
common?
12.
It's
Well,
12.
6 definitely
Honey,
goes.
24 doesn't go into 60.
Honey, man.
It's 12.
It's 12. It's 12.
Knew it.
Do you want to? Let me just show you.
21
Just-
backwards.
so this is like, now I'm going to just do a little short advertisement, okay? Do you guys know what the upside down birthday cake method is?
No.
No,
Let me
never
just
heard
show
of
you.
that.
What is
To
birth-
find the greatest
I
common
just want
factor.
cake, the birthday
To
cake.
find the greatest common factor, if you're ever confused, watch this. If I said
I was gonna say that
24
turns into 2x minus 5.
and 60, okay, here's my upside down birthday cake. I asked myself, okay, what do I know goes in there? I don't know, 2 definitely goes into those 2, right? So that gives me 2 into this is 12, and 2 into this is 30. You agree with me? I'm
Maybe.
dividing 2 into this and I get this. I divide 2 into this and I get this. You with me? And now look, I draw another box a little bit in from the last one. And so it's my upside down birthday cake. I kind of keep, or wedding cake or something. I keep going, right? What? Oh, they're both even again. I could do 2 again. I could do 2 again. So 2 goes into 12 6 times. 2 goes into 30 15 times, right?
This is,
Now watch this. Watch this. You'll see how cool this is.
it looks like a wedding cake.
What can go into both of these?
Gary, you should be a
3.
wedding cake designer.
Yeah. So yeah. That's
You're
what I'm
gonna
gonna do.
design it like big on top,
Okay.
small.
I wonder if they make more money than math teachers do.
No.
Okay. All right.
Caterers?
So 3 into 6, guys, listen. 3 into 6 is 2. 3 into 15 is 5. Okay. What goes into both of these?
Nothing.
Nothing. So we're done.
Except for
So
1.
all you have to do is multiply these 3 numbers together. And what do you get?
12.
12.
Oh my
2
god.
times 2 is 4. 4 times 3 is 12.
So 12 is my greatest common
Yeah,
factor
oh, Gary's a wizard.
between these 2 points.
Also, Gary.
Gary's a wizard.
So now I'm going to do 12
Wizard. You're a
parentheses.
wizard, Gary.
I'm going to divide this by 12, divide this by 12, What do I have?
By the way, I'm not doing that. That's way more work.
So what do I have?
It's 2 minus 5.
2x minus 5.
minus 5. Okay,
Okay,
so
but
now,
wait, you're
now-
teaching us a method that's so
Now-
much longer.
yeah,
So,
so,
oh my
God.
so guys, this is a video, so not too noisy. But that method sometimes is useful. If you were on a, if you were taking a majorly important test and you wanted to be sure you were getting it, that would be good. Now, I'm going to redo this one though, and I'm going to use a different greatest common factor. Okay, I'm going to do the same one again. Guys. I'm going to do the same one again. And so, like Jack said, he thought maybe 6 was the greatest common factor. And it's very easy when the numbers are big to not know, right? You just kind of, sometimes if you don't use the upside down birthday cake or wedding cake method, then let's just try it. Let's do 6, parenthesis, and I divide this by 6 and divide this by 6. And then what would I get? I'd get 4x, right? Minus 10. Do you agree with me? Yes? Right?
Yeah.
Now, look at this. Is there another number I could factor out of these two?
Yeah.
What?
2.
2. So that 2 then becomes multiplied times the 6. So it's really now I'm going to do this.
6.
I'm going to take a 2 times 6, right? The 6 stays, and then the 2 is coming out. Divide this by 2, divide this by 2. That gives me 2x minus 5,
This
which is what I got here, right? Which is 12 now. 12 times 2x minus 5,
Okay.
right? So even if you don't
Gary,
use the greatest common factor, just look at what you put in here. If you're not positive that that's the greatest common factor, look in here and notice, I can take something else out.
Gary, I have one question for you.
Yes.
Why can't we just do it the way we've been doing it? Just like literally like that. Okay, you showed us 3 methods. The one where we just do it really quickly, find the greatest common factor. Then the other, the cake method, which takes 18 hours. Then this one, which takes 24 hours.
No. This doesn't take 24. This is the same method as the first method. The only difference is
You're explaining it.
I'm explaining that sometimes you might not know what the greatest common factor is.
So is that
Let's
to like
say,
check?
Let's say, yeah. Once you factored out the greatest common factor, there should not be something that also can go into both
So
of these.
the way you did it is you wrote 24x minus 16 and just divided it by the half of 12. Divided it by half of their greatest common factor. So their greatest common factor is 12. Then you divided
Right,
it by
I
6
divided by
because
6,
6
but
is half of 12.
Right, but exactly.
Yeah,
So
I thought so.
eventually you're going to have to, if you look inside what you factor, your result of your factoring out.
I got it. I got
If
it.
something goes into both of those, you're not done. Does that make sense?
Yeah.
You didn't get the greatest common factor. You got a factor, but not the biggest.
Yeah, I get
So,
it. It's simple.
That's all I'm saying.
This
So, okay. So that's basically it. So homework tonight is pretty straightforward. It's just working on these so that you get good at them. But I call this factoring out the greatest common factor. I don't think anybody else does. I call it the golden, I call it the golden rule of factoring. Because it is so important. It's the first thing. When somebody says factor, including quadratic equations, when they say factor, this is the first thing you always try. It's the first thing. Always try to factor out the greatest common factor in everything, any kind of factoring over the next 2 months or whatever we're doing, okay, however long we're doing. And that's it. That's it for now. Tomorrow we'll make it a little more challenging. Okay.
Sounds great.